गुड इवनिंग सभी को। नमस्कार, स्वागत है आपका हमारे इस प्लेटफॉर्म पे जिसका नाम है 1 मार्क सॉल्यूशन। जैसा कि आप सभी जानते हैं कि लगातार हमारे साथ डिफरेंट सब्जेक्ट्स के डिफरेंट एक्सपर्ट्स इस प्लेटफॉर्म पे जुड़ते आते हैं, जो कि हमारे जो सब्जेक्ट के 1 मार्क्स के क्वेश्चन होते हैं उनको यहाँ पे एक्सप्लेन करते हैं विद फुल एक्सप्लेनेशन के साथ। और आज जो हमारा टॉपिक है वो क्लास 12th के लिए है, चैप्टर है फिजिक्स और वेव ऑप्टिक्स चैप्टर है। जो हमारे साथ रिसोर्स पर्सन है, मैं स्वागत करना चाहती हूँ सर का। स्वागत करती हूँ मैं। सर का नाम है हितेन परमार सर। और सर पहले भी यहाँ पे बहुत सारे इस प्लेटफॉर्म पे बहुत सारे प्रेजेंटेशन दे चुके हैं अपने, तो जो हमारे व्यूवर्स हैं उनको तो पता ही होगा सर के बारे में। सर पीजीटी फिजिक्स है माई ओन स्कूल जयपुर राजस्थान में, और सर का खुद का भी इंस्टीट्यूट चलता है जिसका नाम है फिजिक्स बाय हितेन परमार। और सर सीबीएसई ट्रेनर भी हैं, टीचर्स को जो ट्रेनिंग देते हैं, और सीबीएसई कंटेंट प्रिपरेशन टीम के मेंबर भी हैं। तो मैं ज़्यादा टाइम नहीं लेते हुए मैं अभी सर को हैंड ओवर करती हूँ। और जो भी हमारे न्यू व्यूवर्स हैं उनको मैं रिक्वेस्ट करती हूँ कि चैनल को प्लीज़ सब्सक्राइब कर दें, जिससे कि आपको जो भी अपकमिंग वेबिनार्स रहेंगे उनके डिटेल्स आपको मिलते रहेंगे। और लास्ट में एक फीडबैक फॉर्म आएगा कमेंट बॉक्स में, लाइव कमेंट बॉक्स में, जिससे कि आप जो अभी सर प्रेजेंटेशन देने वाले हैं उससे ही रिलेटेड 10 क्वेश्चंस रहेंगे, और 4 अगर आप क्वालिफाई करते हैं देन आपको एक सर्टिफिकेट भी इशू होगा। ज़्यादा से ज़्यादा लिंक को शेयर कर दीजिए और चैनल को सब्सक्राइब कर दीजिए। स्टे विद अस। ओके सर।
Good evening, good afternoon, everyone. I hope this pandemic is not troubling a lot to the students, at least related to class 10th and 12th, because some way or the other you have to subside the scenario and concentrate on your content, on your studies. In this continuation, in this lead only, one mark is helping us a lot and leading us to the new concepts added to the CBSE curriculum, or the linkage provided between the CBSE curriculum and the competition exams. That is, 1 mark questions, MCQ formats, or whatsoever it is. They're all the same kind. If I remove the 4 options, it becomes a fill in the blank. If I change the language, it gets to a 1 mark question. Basically, it is a concept that is being discussed in these 1 mark questions. Ma'am, sharing is on.
Yes sir, yes sir. Yes sir, it's on.
Now, coming to the topic wave optics, chapter number 10, a part of the unit wave optics. The complete unit, as I've discussed earlier, with ray optics also has a weightage of 14 marks, and of which a very good portion, around 2/3 of it, is ray optics, and 1/3 of it is provided to wave optics. Wave optics has its own importance because all the phenomena that we study in ray optics, the one that we talk about as reflection or refraction, the laws I is equal to R, or mu is equal to sin I by sin R, or V1 by V2, all these laws are explained not under ray optics. The reasons for it lies under wave optics only. Important points to remember from wave optics that for CBSE are to be considered as: one is light is a form of energy that generally gives us the sensation of light, and that light is said to be following, or it is explained by various theories. Newton's corpuscular theory, that basically controls the ray optics part. It is based on rectilinear propagation of light, that light propagates in form of very small particles known as corpuscles, and color of light is due to the various sizes of the corpuscles that leads to the wavelength or the frequency of it. Next is the wave theory given by Huygens. That is what we are going to discuss on in this chapter. It says that light travels in a hypothetical medium, either as waves. Hypothetical medium ether. Ether is the medium that has high elasticity but very low density. Basically, all the studies, all the researches in physics or as well as chemistry, they are done in this particular hypothetical medium ether. They talked of this particular medium only, and then they generalized it all as a whole. Huygens proposed that light waves are of longitudinal nature, but later on they were proved to be of transverse nature. Maxwell theory that says that light travels in form of electromagnetic waves. That means it has electric and magnetic field oscillations, and it was later on proved that every electromagnetic wave travels such that the direction of propagation of light or the wave, the electric component of it, the magnetic field component of it, all the three are mutually in perpendicular directions. And electromagnetic waves, according to Maxwell, they does not require any material medium to travel. He says in free space, the speed of light c is 1 by root of mu naught, that is root of the permeability in free space, and epsilon naught permittivity in free space. And this value leads to 3 into 10 to the power 8 meter per second. Then Einstein also played his own role in it. Einstein's quantum theory says that light is produced, absorbed, and propagated as packets of energy called photons. Energy of one photon, one quanta, one packet is E is equal to h nu. Nu is frequency, and it can always be replaced by C by lambda. And so we get E is equal to h nu is equal to C by lambda according to Einstein. And the last and very important theory was given by de Broglie. De Broglie dual theory of light. He says that light propagates both as particle as well as wave. That means all the four theories that we have discussed just now, they all collectively explain what light is. Wave nature dominates when light interacts with light. Wave nature dominates when light propagates. Wave nature dominates when light superimposes with another light, whereas the particle nature dominates when light interacts with the matter, when light goes and collides to some particle, when microscopic or macroscopic sort of particles they come into the path of light, then the particle nature dominates, that is corpuscle theory comes into motion. When it is traveling, when it is interacting with light, or when it is interacting with something else with energy content, then it is wave nature, and then Huygens at this point becomes important. All these theories, the corpuscular theory, the wave theory, the electromagnetic wave theory, the quantum theory, and the dual nature theory. Corpuscular, Newton; wave theory, Huygens; electromagnetic wave theory, Maxwell; quantum theory, Einstein; and dual theory, de Broglie. And these are various phenomena that are related to light given in the left column. Which theory is able to explain which phenomena? If you just look at it, rectilinear propagation is explained by all of them. Reflection is explained by all of them. Refraction is explained by all of them. But then on, there is no such phenomena that is explained by all of these theories. Electromagnetic wave theory given by Maxwell, wave theory given by Huygens, and dual theory given by de Broglie. All the three talk about wave nature of light. And if you look at this table, all the 10 phenomena are explained by dual nature. 9 of these 10 are explained by the Maxwell concept and the Huygens concept. This tells us where it is that important that wave nature of light should be studied. This itself can be a question. Interference can be explained by which of the following, or cannot be explained by which of the following theory. If 4 options are given, you have to find which effects of which explains the interference pattern of light and which it does not. So this table becomes very important. When we talk of wave theory, the very first term that comes into our mind, that comes on our tongue, is wavefront. The locus of all particles in a medium vibrating in the same phase at a given instant of time is called wavefront. A wave always propagates. The direction of propagation of light is always, it is propagating perpendicular to the surface of the wavefront. every point on a given wavefront. A point source has a spherical wavefront, a linear source has a cylindrical wavefront, a source at infinity has a plane wavefront. Every point on the given wavefront acts as a new source of disturbance or wave. As we many times we have studied in the past in junior classes, that a line is collection of number of points. Just like that, wavefront is a surface that is collection of a number of point sources of light. And every point on that wavefront acts as a new source of light, a new source of disturbance. And this travel in all the directions with the velocity of light in the medium. A surface. These disturbances that we call secondary wavelets, they collectively form a surface. The surface touching these secondary wavelets tangentially in the forward direction at any instant defines or tells us about the new wavefront, and that is known as the secondary or the next wavefront. And that is how light propagates in form of one wavefront to another, second to the third, and so on. Wavefront always travels in the forward direction of the medium only. There is one law given by Kirchhoff that rules it over here. It says that wavefront cannot travel in the backward direction. Light rays is always normal to the wavefront. Whenever you draw the diagram, the direction of light ray has to be perpendicular to the direction of the surface of the wavefront. And the phase difference between various particles on a given wavefront has to be zero, as it is collection of points in the same phase. The phase difference has to be zero. Waves strictly follow the principle of superposition of vectors. When two or more than two vectors superimpose, it is what we call it in principle of superposition for vectors. Here we call it in terms of waves. When two or more waves superimpose over each other at a common particle of medium, then the resultant displacement of the particle is equal to the vector sum of the displacements produced by the individual waves. If y1 is displacement of wave 1, y2 is displacement of wave 2, then the vector sum of y1 and y2 would give you or would provide you the net displacement. Phase. When we talk about waves, these terms that you have studied in class 11th are to be re-mentioned over here. The argument means in sine theta, theta is the argument. The argument of sine or cosine, that is the angle that is attached to the term sine or cosine, in the expression for displacement of wave is defined as the phase of the wave. सिंपल लैंग्वेज में बात करें तो फेज किसी भी फंक्शन या एक्सप्रेशन का ट्रिग्नोमेट्रिक फंक्शन के साथ जो एंगल चल रहा होता है, दैट इज व्हाट इज नोन एज फेज. For displacement y is equal to a sine omega t. Y is the displacement of the particle vibrating in a plane. A is the maximum displacement at any given instant of time, that is the amplitude of the wave. And omega t is the phase at any given instant t. Phase difference. If two waves are represented as y1 is equal to a1 sine omega t, the phase is omega t. For the other wave, y2 is equal to a2 sine omega t plus phi. This omega t plus phi is the phase. For second equation, phase difference means the difference of the phase of the two. Subtract the angles, subtract the phases. Omega t and omega t gets cancelled, and the phase difference is phi. Similarly, there's a path difference. If phases are different, then the amount of distance traveled, the path traveled, is always going to be different only, and the difference of paths traveled by the wave in that same instant where we calculated the phase difference as phi is known as path difference, and it is calculated as del is equal to lambda by 2 pi into phi. When superposition takes place, amplitude and intensity of the new waveform is to be calculated. Suppose the two waves, as I told you, y1 and y2 having the expressions a1 sine omega t and a2 sine omega t plus phi superimposed, where a1, a2 are the individual amplitudes, phi is the phase difference between the two, and I1, I2 are the individual intensities. After superposition, the resultant amplitude by the vector formula of addition, it is given as A is equal to a root over of A1 square plus A2 square plus 2A1 A2 cos phi. Maximum, it is A1 square plus A2 square. Phase difference is 90 degree. Then it is A1 square plus A2 square. Maximum is A1 plus A2. Minimum is A1 minus A2. These are various things that you have studied in class 11 in the waves part as well. The resultant intensity I is given as I1 plus I2 plus 2 root of I1 I2 into cos phi. Because intensity is proportional to the square of amplitude, that is why this relation holds in this manner. I mentioned it over here. As we know, intensity is proportional to amplitude square. I1 is equal to K A1 square, I2 is equal to K A2 square, and I is equal to K A square, where K is any constant of proportionality. If I multiply both the sides of the amplitude formula by K, I get this relation as I is equal to I1 I2 plus 2 of root I1 I2 cos phi. One more term that is very common with this chapter is coherent and non-coherent sources. Coherent, the one who have similar or same inheritance, the one they are inherited, they are obtained from the one same single source. They are known as coherent sources of light. If light is introduced or taken from two coherent sources, then the light obtained by the two has to be 100% identical under all circumstances. Two coherent sources means they provide us exactly the same kind of light, same wavelength, same frequency, same phase or constant phase difference, pitch, amplitude, everything has to be the same. In superposition, there is a phenomena that is very much studied in class 12, the interference of light, and the major portion of your theory questions come from this only in terms of YDSE, Young's double slit experiment, is an example of interference of light only. Interference of light is superposition when two waves of same wavelength traveling in the same direction have almost same intensity superimposed. When two waves of exactly same frequency, that means they are coming from two coherent sources, travel in a medium in the same direction simultaneously, then due to their superposition at some points, intensity of light is maximum and at some points it is minimum. This phenomena of overlapping or producing maximum and minimum is known as interference of light. Interference is of two kinds, basically constructive and destructive. As the name depicts, constructive leads to maximum value and destructive leads to minimum value. When the waves meet at the point with same phase, it means when crest superimposes the crest and the trough superimposes the trough, the nodes, the antinodes, they superimpose each other only, then it is known as constructive interference. In constructive interference, the phase difference between the two waves being superimposed has to be either 0 or 360 or 720, that is 0 radian, 2 pi radian, and so on. Phase difference has to be even multiple of pi, I can say so. And the path difference has to be integral multiple of the wavelength of the wave, even multiple of lambda by 2 or integral multiple of lambda. Then only constructive interference would take place. In destructive interference, generally the crest is superimposing the trough. The crest and trough are superimposing each other. That means positive and negative amplitude are going to compensate or nullify each other in destructive interference. Minimum light is obtained. The phase difference in this case is 180 degree, and the path difference in this case, it is given by odd multiple of lambda by 2. I can also say that the phase difference is odd multiple of pi, and path difference is odd multiple of lambda by 2, and in constructive it is even multiple of pi and even multiple of pi by 2. Young's double slit experiment, as I told you, is the biggest part of this chapter in theory exams, and many times 5-mark question appear from it. Some features of it is the central fringe is always bright because at central position phi, the phase difference, the path difference, both are almost zero. The fringe pattern obtained due to a slit is more bright than that due to a point. Slit means a very thin, a very fine rectangular slit. If you touch your two fingers, and if the gap between the fingers can be considered as a slit, then this is can be considered as a portion where from light travels out, then it is what is known as slit. Fringe pattern obtained due to a slit is more brighter than that due to a point. If the slit widths are unequal, Young's double slit, it has to be used with two slits. If the slit widths are unequal, the minima will not be completely dark. For very large width, uniform illumination occurs. So it has to be neither very less nor much high. If one slit is illuminated with red light and another is illuminated with blue light, then no interference pattern would be obtained. Only monochromatic light of one single color, light of one single wavelength is used for interference phenomena to be observed through Young's double slit experiment. If two coherent sources consist of objects and its reflected image, the central fringe is dark. If the two sources, one is object, the other is reflected ray from that object, then the central fringe is dark instead of being bright. Path difference between the interfering waves meeting at a point P on the screen is always given by xd by d. Small d is the distance between the screen and the slits, or capital D is the distance between the screen and the slits. Small d is the distance between the two slits, capital D is the distance of the screen from the slit. And the path difference is given by x into the distance between the slits upon the distance between the slits and the screen. And this is also equal to d sine theta, where theta is the angle made by the two slits at that particular point. For minima and maxima, the conditions, as we already discussed, are del is equal to n lambda and del is equal to 2n minus 1 lambda by 2. In interference phenomena, all the fringes are of equal width, and that width is given by lambda capital D by small d, and angular fringe width of each is beta by d or lambda by d. Lambda by small d or beta by capital D. Beta is the fringe width, lambda is the wavelength. In the whole, Young's double slit experiment setup is taken in another medium. If the whole setup is taken from air to some other medium, then lambda changes. The lambda becomes lambda by mu, and the formula for fringe width, beta formula has lambda in the numerator, so it would also become divided by mu. So the new lambda would be lambda by mu. The new fringe width would be beta by mu. Everything where lambda is, the quantity would be divided by mu. Conditions to get proper sustained interference. Sustained interference means the interference that we can observe. The initial phase difference between the interfering waves remain constant. Otherwise, the interference would not sustain. The frequency and wavelength of two waves should always be equal. If not, the phase difference will not remain constant, and so the interference will not be sustained. Sustained interference means where the interference pattern or phenomena can be observed and studied. The light must be monochromatic for sustained interference. We have generally discussed it. This eliminates overlapping of patterns. The amplitude of waves must be equal. This gets a better contrast, a better brightness of the fringes, intensity of the fringes. The sources must be close to each other. Smaller should be the value of small d. One more phenomenon that we study in this chapter is diffraction. The third is polarization. Diffraction. Phenomena of bending of light around the corners of an obstacle or aperture of the size of the order of wavelength of light. When ray of light moves in form of a beam, then bending of light takes place at the odd corners of the obstacle. That phenomenon of bending of light at the corners of the obstacle or the aperture is known as diffraction. It is the characteristic for all type of waves, each and every kind of waves. They show this phenomena. Greater the wavelength of the wave, more diffraction would be observed. Experimental study of diffraction was done by basically Newton and Young. Young modulus you have studied in class 11, that Mr. Young. Most systematic study was carried out by Huygens, but that was on the basis of wave theory only. Diffraction phenomena is of two kinds. Just introductory इसको आप याद रख लें, एक फ्रैजनल डिफ्रैक्शन, एक Fraunhofer डिफ्रैक्शन. वैसे और कहीं इसको कुछ काम में नहीं आता है. The last phenomena in this chapter that we have to talk about is polarization of light. Light generally travels or propagates as transverse electromagnetic waves. The magnitude of electric field is much larger as compared to magnitude of magnetic field. If you are ever being told to look directly into the eyes of the sun, or if you are being told to look directly towards a point where welding arc, where gas welding is taking place, it is not that easy to stare or look at these two places. Why so? Because very harmful or heat radiations are emerging from that surface, and the eye surface or the eye cells, they start feeling some irritation. What is the solution for that? But if instead of looking at it with naked eye, I would have been looking at it through a Polaroid. Polaroid is not available or some rare sort of lens sort of thing. Every good quality goggle has a Polaroid in it. If you have a calcite crystal at your place, if you have any good quality gemstone at your place, then it can be used to act as a Polaroid. Polaroid is a material that generally reduces the intensity of light by removing or reducing the electric vector or component of the oscillation taking place in it. The magnitude of electric field is much larger as compared to the magnitude of magnetic field for a wave, and that is why it has very, very large intensities. We generally prefer to describe light as electric field oscillations and not magnetic field oscillations, whereas both kind of oscillations are taking place in it. The light that is propagating, that is traveling, that is vibrating in all possible directions. That is how it comes from the body of, by the origin, from the origin. The light having electric field oscillation in all directions in the plane perpendicular to the direction of propagation is called unpolarized light. Light that is propagating in all possible directions. That means the particle is vibrating in all possible directions, and because of that, the intensity of light is much, 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 much high. But when it passes through a polarizer, of the many angles or components of these electric vector, a vector is said to be made up of infinite number of vectors. It can be always represented as a sum of infinite number of vectors. Only one perpendicular component stays back, then it is known as polarization of light. Polarized light, the light that has oscillations only in one plane. Unpolarized light that has oscillations in all possible planes. Polarized light that has oscillations only in one single plane. The plane in which oscillation occurs in the polarization light is known as plane of oscillation or plane of polarization as well. And light can be polarized by transmitting through certain crystals, such as tourmaline crystal. Tourmaline is a jet black, dark black, transparent gemstone that you people might have seen. The material that causes or that carries out polarization are known as Polaroids. Polaroids naturally are nickel crystal or tourmaline crystal sort of things. Sugar solution can act as a natural polarizer. But artificial polarizers are made by making a coating of, covering a coating of very thin film of ultra microscopic crystals of quinine iodosulfate. Quinine iodosulfate is a chemical. And if a coating of it, if a very thin layer of it is covered over any specs or any glass body, then it starts acting as a Polaroid. Polaroids allow the light oscillations parallel to the transmission axis. It's fine. Malus law and Brewster law controls Polaroid. You all, if you have studied this chapter at some place, are much acquainted with it. Very simple concept. Malus law says that the intensity of light moving out of any analyzer, the very first body in which ray of light enters, is the polarizer. Then the second, third, fourth, fifth, all the ones that come after it, of course, they are also polarizers, but they all are given the name analyzer because they analyze, they judge the light polarized from the first one. If with the help of polarizers you are supposed to stop light from traveling, what would you do? If I put the two Polaroids, the two polarizers at right angle to each other, then no light would pass through them. Is it done? So I depends on, so I is proportional to cos square theta. Malus law states that the intensity of polarized light transmitted through the analyzer varies as the square of the cosine of the angle between the plane of transmission of the analyzer and the plane of the polarizer. That means I said the first one is polarizer, the second, third, fourth, all are analyzers. And if all these analyzers, they make an angle theta with the previous one, then the intensity of light coming out from it is directly proportional to the square of cosine of that particular angle. So I is equal to I naught cos square theta, where I is the intensity received after the analyzer and I naught is the intensity of the light falling on that analyzer. Brewster law, the last theoretical concept, then we'll talk about some questions. Because again, the basic issue is there are some chapters which do not have much number of one marker questions. They appear from this part that we have discussed only from this chapter. Otherwise, it has detailed questions only. Brewster law, Brewster said that when a ray of light falls on any refracting surface, a part of it gets reflected and a part of it gets refracted. If the reflected and refracted ray are mutually perpendicular to each other, if the reflected and the refracted ray, in the figure in front of you, the two rays that are towards the right of the normal, the bottom one is the refracted ray, the one that is up in the same medium, initial medium, is the reflected ray. If this reflected and refracted ray are at right angles to each other, then the reflected ray is polarized light and the refracted ray is partially unpolarized light, and this takes place only when the angle of incidence, the theta p, is such that it is equal to tan inverse of the refractive index of the medium. That is, mu is equal to tan theta p. Theta p can now be called as angle of polarization. And these are the uses of Polaroids. You can just read it. It is used in determining the polarizing angle. Brewster Law is used for it. It reduces glare. You can, after wearing it, you can straight sun. You can look at straight in the sun. In calculators and watches, numbers and letters are formed by liquid crystals, and that is done through LCD, liquid crystal display, and that is polarization only. In CD player, polarizers laser beam act as a needle for producing. There's a lens sort of thing in a CD player that makes laser light fall on the CD and it is read then. That is also a polarizer process. It has also been used in recording and reproducing 3D movies. Polarization of if you have ever gone to cinema for a 3D movie, then the specs that you are provided are polarizers only. Polarization of scattered sunlight is used for navigation in solar compass in polar regions. Okay, these are various uses of polarizations. Now, some questions to be discussed. No major trick or concept we can talk of in wave optics, but still, I tried to connect you with some questions, some specific kind of questions, and if anything related to the topic would appear over there, then I would explain it there and then only. Light, as we all say, travels from sun to us. The source is infinity. The wavefront that we are receiving is a plane wavefront. A plane wavefront or a plane body is always considered as a very, very, very small part of a spherical body that you have to always keep in mind while carrying out with moving out with the questions. Very first question: if two light waves having same frequency have intensity ratio 4:1, two light waves having same frequency means someday or other they are going to introduce interference, and they interfere, the ratio of maximum to minimum intensity in the pattern will be intensity of maximum upon intensity of minimum is given by either of the formulas. Either you use root I1 plus root I2 upon root I1 minus root I2 whole square, or dividing both the sides, numerator and denominator, by root I2. You get the relation that is written in front of you. Root I1 by I2 plus 1, root I1 by I2 minus 1. This is used because the ratio of intensities is given over there. So root I1 by root I2 would be always equal to 2 in this case, 2 plus 1, 3 upon 2 minus 1, 1. So 3 by 1 square, it is 9 by 1. Option A is the correct answer. In a Young's double slit experiment in YDSE, using sodium light of wavelength 5898 angstrom. Angstrom means 10 to the power 10, 10 to the power minus 10 meter. In Young's double slit experiment using sodium light with a wavelength of 5898 angstrom, 92 fringes are seen. If the green color is used, the wavelength of green is always also given, the wavelength of sodium light is also given. How many fringes would be seen? It's a very simple formula. N lambda is always constant. N1 lambda 1 into N2 lambda 2. N1 is 92, lambda 1 is 5898. N2 is to be calculated, lambda 2 is 5461. So N1 lambda 1 is equal to N2 lambda 2. 92 into 5898 is equal to N2 into 5461 divided by 92, and you get the answer as N2 is equal to 99. Because there is option D is the correct answer. Next question: two beams of light having intensities I and 4I interfere to produce a fringe pattern on a screen. Fringe pattern means a pattern having stripes, dark, bright, or stripes of different colors. Generally, if you ever used a torch. If you rotate the front portion, the reflective portion of the torch, and make the wall of the room a screen, then the light on that screen, that wall, many times appears in form of fringes formed, circular patterns, and these are what we call fringes. Two beams of light having intensities I and 4I interfere to produce a fringe pattern on a screen. The phase difference between the beams is pi by 2 at point A and pi at point B. These are two different points, A and B, where phase difference at point A is pi by 2 and at B is phi. Then the difference between the resultant intensities, okay, at A and B. Intensity is defined as I is equal to I1 plus I2 plus 2 root of I1 I2 cos phi. At a point A, resultant intensity where the phase difference was pi by 2. Substitute the value as pi by 2 and you get it as phi phi. If I substitute the value of phi as pi, I get it as I, and thus the difference of phi and I is 4I, option B. Two waves are represented as y is equal to 4 sine omega t and y2 is equal to 3 sine omega t plus pi by 3. If they interfere at a point, the amplitude of resulting wave will be about. Amplitude would be about after superposition. How can you calculate it? Amplitude is given by under root of a1 square plus a2 square plus 2a1 a2 cos phi. तो सबको पता है ये. Now if a is equal to 4 is amplitude of 1, 3 is amplitude of 2, 4 square plus 3 square plus 2 into 4 into 3 cos pi by 3 is phi. Okay, so it gives you root 37 or approximately 6 is the correct answer. Two waves produced by two sources S1 and S2 having zero phase difference and having wavelength as lambda. Destructive interference of both occur at a point P. Destructive interference at point P. That means you have to get the difference of it, S1P minus S2P. Destructive crest is overlapped by trough. The value of S1P minus S2P would be, we know that destructive interference, the path difference is given by odd multiple of lambda by 2. Odd multiple of lambda by 2. All these, the odd multiple of lambda by 2 is only given by option D, 11 lambda by 2. So that is your answer. To interfering waves having intensities 9I and 4I and having a path difference 11 lambda between them, the resultant intensity at these point will be. Just take a second and solve it. Sorry, why the solution is being given. Can you think of something? Two interfering wave having intensities 9I and 4I, path difference 11 lambda, the resultant intensity at this point will be. The two interfering wave, if they have a path difference of lambda, 11 lambda, then it means that lambda by 2 pi into phi. Phi is 11. We can calculate the value of phi from this. Del is lambda by 2 pi into phi. Del is given as 11 lambda. Can you calculate the value of phi from it? Just if we transpose it from the one side to the other, you get the value as 2 pi by lambda into 11 lambda, and that comes to be 22 pi. the phase difference phi is 22 pi. For constructive interference, the resultant intensity is given by under I1 plus I2 ka square, and then if it is even multiple of pi, it is constructive interference, and then we can get the resultant intensity as 25 I. In interference, if I maximum upon I minimum is 144 by 81, then what will be the ratio of amplitudes of the interfering waves? In interference, if I max upon I minimum is 144 by 81, then what will be the ratio of amplitudes of the interfering wave? There is a same formula that we use in very first question that we discussed. A1 upon A2 is equal to root of I max upon I minimum plus 1, I max upon I minimum minus 1. There we have talked about I1 upon I2 and it was in terms of square. If we are not talking about I1, I2, then it would be A1 upon A2. The square would be removed and the resultant that you'll get is 7:1. Light coming from a star is observed to have a wavelength of 3737 angstrom, and its real wavelength is 3700. The real wavelength is 3700 angstrom. The apparent wavelength that appears to us is 3737 angstrom. The speed of the star relative to the Earth is 3 into 10 to the power 5 meter per second. The speed of star relative to Earth is 3 into 10 to the power 5 meter per second, or 3 into 10 to the power 6 meter per second, or 3.7 into 10 to the power 7 meter per second. Of the four options, what it would be? Light coming from a star having a wavelength of, while its real wavelength is 3700. A bit of Doppler effect sort of thing can be used, or we can do it straight. The difference in wavelength, that is 3737 minus 3700, 37. Difference in wavelength has to be equal to lambda, the original wavelength, into V by C. V, how would you calculate V? Put the values in the formula. Delta lambda, the change in wavelength, is given by 3737 minus 3700, that is 37. Lambda is 3700. C is 3 into 10 to the power 8. You can very easily calculate the value of V. That V would come to be option B, 3 into 10 to the power 6 meter per second. In Young's double slit experiment, an interference pattern is obtained on a screen by light of a wavelength 6000 angstrom coming from the coherent source, and at certain point on the screen, third dark fringe is formed. Then the part difference to be calculated in microns. That means in terms of 10 to the power minus 6 meter, it is to be calculated. For dark fringe, part difference del is equal to 2n minus 1 lambda by 2. For n is equal to 3 in this case. As per the equation, third dark fringe is n is equal to 3, and lambda is equal to 6000 angstrom. That means 3000 into 10 to the power minus 10 meter. If I substitute the values in the formula, I get delta as 1.5 into 10 to the power minus 6 meter, that is 1.5 microns. Again, in a Young's double slit experiment, the slit separation is 1 millimeter. Small d is 1 mm. And the screen is 1 meter from the slit. Capital D is 1 m. 1 mm means 10 to the power minus 3 meter kilo. या 1m कैथोड 1000 mm के बराबर. For a monochromatic light of wavelength 500 nanometer, 500 into 10 to the power minus 9 meter, the distance of third minima from these central maxima is. The straight formula for distance of nth minima from central maxima is given by x is equal to 2n minus 1 lambda d, capital D upon 2 small d. You know the meanings of all. N is the number of fringe. Third fringe. It was third only? Yes. Lambda is the wavelength given as 500 nanometer. 500 into 10 to the power minus 9 meter. Capital D is 1 meter. And small d is 1 millimeter, that is 10 to the power minus 3 meter. If we substitute the values, we get the answer as 1.25 millimeter. The two slits at a distance of 1 millimeter. Whenever we talk of two slits in any question, the concept of interference through Young's double slit experiment would be considered. But if they ever start talking of that one of the slits is covered with something, or if they say it's single slit experiment, then it is nowhere similar to it. There's a hell lot of difference between the two. In that case, only one single slit or an obstacle is taking place, or it is placed in the path of light. In this question, again, there are two slits, so YDSE, Young's double slit concept, will be working on it. The two slits at a distance of 1 millimeter are illuminated by the light of wavelength 6.5 into 10 to the power minus 7 meter. The interference fringes are observed on a screen placed at a distance of 1 meter. The distance between the third dark fringe and fifth bright fringe. If it is nth dark or nth bright and nth dark fringe, and n is more than m, then what would happen? You substitute the values of n and m in this formula, n minus m plus half into beta. N minus m, n is 5, m is 3, and beta is lambda d by d. Substitute the values, lambda would be simply replaced by that 6.5 into 10 to the power minus 7 meter, because other factors would get nullified. And it is 5 minus 3 plus half, 2.5, 5 by 2 plus whatever it comes to be, into 5 by 2 into lambda d by d, 10 to the power minus 4, 6.5 into 10 to the power minus 4. So it is, finally the answer would be 1.63 into 10 to the power minus 3 meter, or 1.63 millimeter. Two slits of equal width having same source, and they are placed symmetrically relative to the slits. The intensity at central fringe is I naught. Okay. If one of the slits is closed, if you close one of the slits, it starts getting diffraction pattern. In diffraction pattern, the intensity continuously decreases. If the intensity of the central fringe is I naught, then intensity of first maxima is I naught upon 1.5 pi ka square, then 2.5 pi ka square, then 3.5 pi ka square, and so on. And according to that, now you can get the answer very straight. The intensity at this point would be, it has to be I naught by 4. I is equal to 4i cos square phi by 2. Because they are of same intensities, it goes to be 4i. And if I substitute the values over here, phi is 0, I naught I did as 4 pi, 4i already, then the answer of I, it would get 1/4, because it is in whole square form. So you would get it as option B, I naught by 4. In double slit experiment, the angular width of the fringes is 0.2 for sodium light. Lambda again, it is 5898. We Many times take it rounded off as 6,000 as well. 5890 or whatsoever the value is provided in the question is important. In order to increase the angular width of the fringes by 10%, the necessary change in the wavelength is it would increase by 589, decrease by 589, increase by 6479, or it would be 0. Theta is lambda by d, the angular separation, or theta 1 by theta 2 is lambda 1 by lambda 2. And if the angles are known for them, 0.20 upon 0.20 plus 10% of it, as they say, angular width increases by 10%. So the new angular width would be theta plus 10% of theta. And from this we can calculate lambda 2 to be 6479. That's 6479 minus 5890. So here you will get the difference as 589 angstrom. In Young's experiment, light of wavelength 4000 angstrom is used and fringes are formed at 2-meter distance and has a fringe width of 0.6 millimeter. If whole of the experiment is formed in a liquid of refractive index 1.5, the fringe width also decreases by the same factor 1.5. Very simple. If the fringe width is previously 0.6, the new fringe width is 0.6 upon 1.5, that is 0.4. Two identical sources producing intensity of K, two identical sources emitted waves which produces intensity of K unit. At a point on screen where path difference is lambda, what will be the intensity at a point on screen at which path difference is lambda by 4? If intensity of K unit for path difference lambda, that means they are talking about relation between intensity and path difference or phase difference. If the path difference gets 1/4, the intensity would get half. If the path difference gets doubled, then the intensity would get 4 times. It is like that only. The phase difference is given by the formula 2 pi by lambda into path difference. And for path difference lambda, phase difference 2 pi. In second case, it is lambda by 4. So if it gets to be lambda by 4, then the new phase difference would become as pi by 2. Substitute the values and get it. Now, I is equal to 4 I naught cos square phi by 2 wala concept, and that would lead you to I2 is equal to K by 2. A thin mica sheet of thickness, this is a bit different, not for CBSE. Generally, this is for competitions only. A thin mica sheet of thickness m and refractive index mu is introduced in the path of the first wave. One of the two beams leading to interference on the screen has this effect in between before superposition. The wavelength of the wave used is 5000 angstrom. Central bright maximum would shift. The shift would be given by the formula P by lambda, bracket mein mu minus 1 T. T over here is 2 into T is given a thin mica sheet of thickness m. It is given as 2 into 10 to the power minus 6 meter. That is a misprint in the question. That is what I was looking for. The difference in mu minus 1, difference in the refractive index in 1 would be 1.5. Beta, in terms of beta only the answer is, so yes, del x is equal to beta upon 5000 into 10 to the power minus 10. Mu minus 1 is 1.5 minus 1, that is 0.5. T is 2 into 10 to the power minus 6 meter. And as you resolve it, it would lead to the answer is 2 beta. Since the sheet is placed in path of the first wave, it would displace the fringes by twice the original fringe width. Same kind of questions are there. This is also in YDSA fringes are observed by using light of wavelength 4800 angstrom. If refractive index 1.5 is introduced in the path, one of the wave, and the plates is introduced in path, look, there is medium introduced in both the waves this time, 1.5 in one and 1.8 refractive index in the other. In this case, what would happen? Look at the figure, you would understand what actually the question is talking about. In this case, you have to calculate x1 and x2, that is beta by lambda mu1 minus 1 into t, and beta by lambda mu2 minus 1 into t. Beta would be same for the two, lambda would be same for the two, t, if it is given in the question, t. Thickness of the plate is same for the two. So now the net shift would be x2 minus x1, because one would be shifting it up, the other would be shifting it down. The net shift would be difference of the two. And if we calculate the difference of the two, we get it to be 8 micron. A star moving towards the Earth with a speed of 4.5 into 10 to the power 6 meter per second. True wavelength of a certain line in the spectrum received from the star is 5890. What would be its apparent wavelength? Apparent wavelength, lambda dash, Doppler effect, class 11th. Lambda dash is equal to lambda 1 minus V by C. Substitute the values straight away. V is 4.5 into 10 to the power 6, C is into 10 to the power 8, lambda is 5890. Substitute the values to get it as 5802 angstrom. D by D, the ratio of the separation of slits and separation of slit and screen is given by 10 to the power minus 4. At a point P on the screen, resulting intensity is equal to intensity due to individual slit, I naught. Distance of point P from the central maxima. Direct straight formulas. Triangle Dale, path difference is equal to lambda is equal to xd by d or nd by d. And just if you go on the calculation part, d by d is given to you, substitute it over here, you can get the value of x as 2 into 10 to the power minus 3 meter. Exactly same kind. If I is intensity due to source, path difference is 3 lambda by 2. A very simple straight concept can also be used. Look at the question again. I is the intensity due to a source of light at any point P on the screen. If light reaches the point P via two different paths, of course the interference is taking place, then two different paths, A and B. After reflection from the mirror, A is direct path and B is coming after reflecting from a mirror. Then of course the path difference between the two paths they are talking about is 3 lambda by 2. The intensity at point P is to be calculated. Reflection of light, it gives an additional path difference of half of the wavelength, lambda by 2 between the waves. So total path difference that is developed after refraction, 3 lambda by 2 as per the equation and lambda by 2 as per the condition given in the equation. So it is equal to 3 lambda by 2 plus lambda by 2, 4 lambda by 2, 2 lambda. And this 2 lambda, it is a condition that is satisfying n lambda condition, that is constructive interference or the maxima. So resultant intensity in the case of maxima is given by root over of I1 plus root over of I2 ka whole square, and it leads to be 4I in this case. Width of one of the two slits is doubled. Of the two slits, width of one slit is double of the other. Assuming that the amplitude of the light coming from a slit is proportional to slit width, so the amplitude in second case would be 4 times square of the double. The ratio of maximum to minimum intensity, that very first formula can also be used, and you can get it from average as well. A max is equal to 2A plus A, that is 3A हो गया उस केस में, constructive वाले में, and A minimum is 2A minus A, that is A. So I max upon A max would lead you to the answer. Width of one of two slits of Young's double slit experiment is double the other. So this is all from wave optics. I hope you all, those who are going to look at this through the YouTube channel of 1 Mark, or those who were live over here, if they were, then it would be benefiting you. If ever you have any sort of doubt, the mobile number is there in the chat box. I just present it on each and every screen as well. Anytime you can drop a message on the WhatsApp for it. Back to Priyanka ma'am.
थैंक यू सो मच सर फॉर दिस ब्यूटीफुल प्रेजेंटेशन और हर क्वेश्चन का आज तो पूरे एक्सप्लेनेशन के साथ एक एक इस चैप्टर का पूरा एक्सप्लेनेशन था और उसके बाद 1 मार्क्स के क्वेश्चन थे तो आई थिंक व्यूवर्स को भी काफ़ी अच्छे से एक्सप्लेन हुआ होगा आप बाद में भी इस प्ले लिस्ट में जाके हमारी यूट्यूब की प्ले लिस्ट में जाके इस चैप्टर को अच्छे से थॉरली आप देख सकते हैं और इसके 1 मार्क्स के क्वेश्चन को कर सकते हैं जैसा कि सर ने बताया अभी और मैंने अभी लाइव कमेंट बॉक्स में फीडबैक फॉर्म शेयर कर दिया है जिससे कि आप उसको फिल कर दीजिए और जो भी आज सर ने सेशन लिया उससे ही रिलेटेड क्वेश्चंस कर दीजिए और अगर आप फिर क्वेश्चंस करते हैं देन आपको सर्टिफिकेट भी इशू होगा चैनल को सब्सक्राइब कर दीजिए जिससे कि आपको अपकमिंग वेबिनार्स के अपडेट्स मिलते रहेंगे थैंक यू सो मच सर थैंक यू